I'd like to share with you some of my experience using Golang to develop web APIs, right? So imagine you are in charge of a critical web API in your company. And by critical, I mean this API that if it has a downtime, the operations are off. So, well, it's a major responsibility. And I've been working with e-commerce, for example. So in my experience, this kind of API involves getting all products available, getting stocks, and this type of thing. And we constantly are on the call for guaranteeing these large operations. And it may sound a bit overwhelming, getting called the middle of the night. It reminds a little bit on how doctors work, except that we have a major advantage here because we can provide a trustworthy and safe service to our clients. And we can actually comment on how our patient's body works. So what we want to achieve as we develop this type of API is that we may say to our clients, come on, bring all those requests. My system actually can handle it very well. And there are a lot of tools for us to develop that, being one of them, the Golang. Golang is a language that was developed in Google, and they released that more than 10 years ago. It has these little cute gophers as symbol. And here I bring the definition as they stated it as they launched. First of all, when they say they provide a designed language for concurrent systems, what they mean is that it takes much less effort to parallelize things. And also, when they say it's strong and statically typed, what they have embedded here is that they are very focused on efficiency and performance. Another thing is that they call it small. And I can state that it's a very small language since it's very opinionated. So they provide us few concepts for us to rely on while constructing our system. And well, about critical web APIs, there are some points of concern when we start developing them. I named 3 of them, and I will exemplify here, being the stability, the performance, and the extensibility. Let's suppose we have this application, which responsibility is to give the products available for a store. The stability is like avoid this type of situation. Our customers, they enter our store, they want to see the products, but they find out it's in a downtime. In e-commerce especially, what we have is a concept called the conversion funnel. And what I mean by conversion funnel is that we attract customers to the store, but if we have some problem or if we have a slow API, they just give up on buying. Buying is an impulsive thing. So if we have an API that is too slow, they'll just get over it, right? They will give up on buying. And you may come to me and say, okay, if I have a slow API with a lack of performance, I can just add some servers or some instances to my system. I will increase my processing power, and the API will be responsive now. Okay, it may be an approach, but it's not very sustainable for some reasons, right? First of all, it's very expensive. Providing all these servers or instances or pods, depending on where you're running. And when you scale out your system, you bump into other limits. For example, the number of connections to a database or the number of connections to another service you rely on. So when we try to run with a good performance our application using the minimum number of instances as possible, we call that a scalable system. Also, another thing to pay attention is how easy is it to expand the functionalities of your system. And that's what I'm calling here extensibility. We have to be able to expand the first abstractions that we provided as a service, because new concepts will arrive and our stakeholders will keep asking for new features. So giving all those points of concern and giving a simple tool, you may ask me, how can I accomplish these goals? Well, I want to give you a hint on how this works. So let's build our first API together. Imagine, though, that we will implement this API that will give us the availability for the products in my online store. Well, let's say we will receive a request, and we will go using one Go routine through each product in my store, checking the availability. I'll have all the data I need to generate the response in the memory, and then I'll generate the HTTP response, for example, if I'm using HTTP, right? So it takes, as you may see in this pink arrow above, it takes some amount of time. But as you may see, there is an opportunity of parallelization there, because we can check for different products in parallel, which is the availability. So let's explore that. In Golang, there is this concept called Go routine, which is like a lightweight thread. And in Golang, it has a very efficient management of these Go routines. It implies that we can open as many Go routines as we need. And that's something very powerful. So we feel free to open a lot of Go routines to parallelize things. There is also this other concept in Golang called the channel, which is a proper structure, I'll not call it structure, a proper tool, I may say, to share data among Go routines. So if we use a channel to combine these availabilities that we checked, we can use the channel to send the availabilities to the Go routine that will generate the response. Using Golang, you don't have, if you are using channels to communicate between Go routines, we don't have to worry about locking, for example, which is a very common mistake that we have when we start parallelizing things. We don't communicate by sharing memory. We share memory by communicating. It's a different approach to this problem. And well, let's see how it goes in the code. Suppose we have this piece of code here. You may say at the beginning that I'm defining the channel expressed by the keyword chan. And for each product, I'm checking the availability. Also, I close the channel at line 26. And after, I process all the responses into generating a response for my request. When we parallelize this code, going to the second scenario I gave you, it doesn't take much effort, as you may see. First of all, there is this go function in the line 23 that is more than enough to start a new Go routine. And also I introduce a new concept here, which is the wait group in line 20. The wait group is our synchronization tool. So we fan out all these Go routines, and we keep waiting the response before we generate the final response to the request. There is another opportunity to gain some performance here, which is, what if I start reading the results for the availability check and keep generating the response as long as they come? So we will fall into a very known concept. I hope you've heard about it, which is called the producer in consumer, which can be represented like this in the code. Actually, we have a Go routine as the producer, and it spreads the processing in several Go routines and send the results to a channel. And also, we have the consumer Go routine reading this channel, doing the post-processing, and it's a deeper parallelization, as you may see. But my presentation is about feelings, right? How does it feel? I hope you have some hint on how I feel, but I will list some things that I feel very comfortable at first. First of all, working with Golang, it's pleasant because it's very fast on compiling, and I feel agile. And even if there is a lot of processing behind the scenes to make memory management effective and to prepare for all these Go routines management and a lot of stuff going on, it compiles very fast and it feels very comfortable. Also, there is this advantage that Golang can run in all operational systems. So we can develop in an operational system and deploy in another. That is something that is very comfortable too. When I think of about the Go routines management, as I told you, it's something that we can feel unconcerned. We open as many Go routines as we want. Independently on that, we can count on the efficiency on managing these Go routines, so we can explore parallelization at a deeper level. Something that I've not shown in my examples is the composition, which is kind of an object orientation, but actually it takes that if you implement a behavior for an interface, now this new type belongs to the type of the interface. So it's like you define very small abstractions to your system, and you keep composing them, creating new types, and you can leverage from all the inherited structures to manipulate your objects. So it's like an object orientation, but simpler. Another thing that is very nice in Golang is that it has a native tooling to perform a lot of things that we really need to perform when we are thinking about efficiency and performance. So testing, manage dependencies, formatting code, running on profilers or benchmarking, it becomes very easy, and it's all embedded in the Go command. So you become independent of the IDE, right? You can use whatever you want. It's all covered by the Golang tooling, and it gives us a lot of autonomy. Another thing that I find out it's really great is that as it's a very opinionated language, they provided a lot of good articles for us to simulate the language mindset. It's like a new way of thinking. In the first moment, it may sound a bit awkward, but feel free to reach me if you want any help about this. Actually, it's a very strong community with very skilled technical people. So it's awesome to have this support. I feel a lot supported. But the main thing that I would really like to pass in my message is that Golang has few concepts to deal with. So it's like having a simple Lego with few different pieces. But you can combine them into creating several concurrence patterns and build really complex designs. As it has these few concepts, it becomes easy to read other people's code. And it's awesome to learn from other people, right? Well, I really like to point out that it's not a paradise, nothing is perfect. And when we think of, for example, Stack Overflow, the community is a very important thing as we are developing. And as you may see, there's a major difference between the number of articles when you compare Golang to other languages that are more popular, like Python, or as I brought here, C#. So when, for example, I'm programming C#, which I use as well, I feel like I can state a question like however I want. For example, oh, I want to build this thing using this tool, and I'm finding this error, but I'm not sure why this is. And I find this very exact statement in Stack Overflow. It's very comfortable. As we are using Golang, I feel like I have to think a little bit more before asking something to Stack Overflow. But another point of view is that, well, as it's a simpler language, I don't feel it will be needed at any time as many articles as for other languages. So it's a dual thing, but, well, we feel like a bit of a different in a new community, right? And being simple, it may be seen as a feature as sometimes something that is buggy, because Golang nowadays doesn't have generics. And by generics, I mean, if you want to iterate through an array or through a map to, for example, check which is the maximum value in an integer array, you have to implement all by yourself, because they are not able to provide now a method that will work for strings and integers and any other type. So you have to implement by your own and reuse it as you want. So for example, if I want to find the maximum in an array, I'll have to go like, for each element in this array, please check if it's higher than the maximum, okay, and return. So I feel a little bored when I have to do this. But the good news is that they are already working on it. So it's something that we are expecting a lot for them to release for Golang 2.0. Also, there is a similar problem concerning error handling. And we call it the boilerplate code. When we repeat a code all the time, the same code. And I brought an example here. I'm preparing to do a put request using my code. And you may see in the first line, I'm marshalling the body. And then I check if there was an error. And then I create the request object. And then I check if there was an error. And then I perform the request in line 13. And then I check if there was an error. And you have to treat all errors, because when a Go routine panics, another Go routine cannot see what has gone on, right? So you have to treat all errors, actually. So there is this repetition. It becomes a little boring too. And the good news also is that they already addressed this problem for Golang 2.0. They are trying to approach it more like a try-catch and the bubbling up. That's something we are expecting a lot too. Well, how I feel about all this? is that we have to risk ourselves and try. The future is ours. Come on, let's try it. It's a very good entry tool for new developers. We can run PEP very fast. And it has a very clean framework. And again, I feel like if you want some help with this, please reach me. I brought here some references. This first one is a book, which is for people who are programmers already. So it's very focused on giving the feeling on how these few concepts work. And there are some introductory here at the right too. This is a presentation, which is very good. And also the tour Golang, it's like a tutorial that they gave for new developers. And from that, we can start already coding, right? Well, I'd really like to thank you, the Women Who Code organization. I really, really feel very thrilled to be here with you. And this QR code leads you to all my social media. So if you want to get in contact, please feel free. And thank you so much.
Thank you so much, Alessandra. Can everyone